So let's start doing some show and tell. Who has robots to show tonight? Hands up. Okay. Usually what I kind of do is kind of sweep across the room. So orange with a cap if you could. I don't know your name.
Robo Girl.
Robo Girl? Okay, excellent.
Are you Robo Girl on video from the videos?
Yeah.
Oh.
Wonderful.
I watched the videos. Great.
Oh, cool. Can't calm down a little bit.
It's love at first sight.
GPS signal.
Hi there. So yeah, I'm Robot Girl, also known as Erin or Erin Robot Girl. I make robots that are sort of like robotic creatures, mainly in the social robotics realm. So this is one of my main ones here. It's called RoboBird. And what's cool about it is that for its beak, it actually uses a beak mechanism whereby both beak halves can open from only one servo. So it makes it look more like a cartoon character. And one of its main capabilities is the fact that it can do different behaviors based off of what hat it's wearing. So you can swap in and out the hats, and it will do all sorts of different things for the different hats.
How are you doing the detection of the hat? RFID?
Yeah, so the hats all have a tag on them, and there's an NFC reader inside of the hat.
That's awesome.
I don't know if anyone was at the Cloud Robotics Hackathon, but for Montreal, this was one of the one of the robots there, and what we did was actually we had sort of like a web app game, and that was displayed on an iPad, which could communicate to one of the RoboBirds, and then depending on if you got a point or not in the game, then it would broadcast that out onto a mesh network. So already we have 2 clouds in the whole project. And then all the robots would receive the messages from the mesh network, and then there would be one attached to a computer running a processing applet, which would upload some data back to my robots. And then there would be another robot that would download some data from my robots that would actually be the scoreboard. So that was what the DF robot was used for, displaying the score, because we had the numbers on the tank treads.
Wow. Cool.
Tell us about your.
Tell us how, we're into the under the covers part too. If you could tell us what's inside.
Sure. So it's really simple. What's inside here is just a Seed Studio Arduino 80K, but it works fine off of a standard Arduino. And that's basically all that's inside.
So it's an Arduino.
Picture your Wednesday meeting.
Oh, my Thursday?
Thursday.
Yeah, so also...
That's okay, that's just Violet. Here comes Violet. Everybody say hello to Violet.
Sorry about that, Wayne.
You don't have to be sorry about that.
So every Thursday I do this online Google Plus hangout called the Robot Party, and it brings together people from all over that build and make robots. So we all get online on Google Plus and we discuss robots and how our robots are built and everything. And actually this Thursday it'll be at Evil Mad Science. So when you join the hangout, we'll all be sort of there, and then 10 other people will be elsewhere in the hangout from around
Finally, a use for Google Plus.
Very good. Thank you very much. And if you could, please show that to Violet. I think Violet will get a real kick out of that.
There's a microphone here. We can get that going. I don't know if we're on it.
Does this help? Is it on? No, you have to turn
Power
it
some
on.
things up.
Okay, well, tell me when I'm live here. Am I live?
We'll get there.
We're getting there. I really like this space. It's nice.
Thank you.
Yes, thank you, Michael.
Yes.
Excellent.
Are we live?
Oh, not live. Hey,
Am
I'll
I
just
on?
check. I'll have a bit of a test with this for a little while. We'll get it going.
Okay.
In the meantime, please.
Okay, so let's continue. So I saw a wave of hands go up, but let's see who's kind of next. There was some more people. Alan, come on up. Are we live? Oh yeah, we're live.
This is my Robo Games
Do you need one back this- you're-
tabletop.
Okay.
This is the Micro Moose 1.
Okay.
There's a little story behind that. I was building a little robot and we came out with the Micro Maze. And oops, it's too big, so it's a Micro Moose. And we put them on a tabletop challenge instead. This is actually an outgrowth of the club's robot. A couple RC servos, Arduino board, battery of course, and I got 6 IR sensors. If we had a table here, it would run around the table and manage not to fall off.
Oh, come on, we have a table right here.
Try it.
There's a folding table over here.
This might be, this
Is
is
there a folding table?
Yeah, it's over here.
Can use the stool?
slightly dangerous, but we
Can
can
you want to try that stool?
Enhancement. This is for extra points.
Okay.
Here's a small one.
Oh, here comes something.
I don't know how well it's gonna work on a small table,
Work like
but
a star.
see the edges. It's supposed to find an object, a small square. There we go. Also needs something to find.
Good. More people have found this place.
Take some notes.
Okay, we now have a table.
Uh, I said it's got 6 IR sensors, two to watch the table and try not to fall off, 2 to try to find an object, like it's probably too low for the mouse. And then once it finds the object, oh, there we go. Let's try that. Over there. It's kind of nearsighted. You might have to sneak up on it a little bit.
I think our speaker has just found the place.
No, come over here. Over here.
There we go.
Okay, find an object. That's a new dimension. Find it, grip it,
Gripper action.
and depending on what mode we are, we either shove it off the edge, or if we had a box, we'd put it in the goal box. So that's a tabletop for you.
Okay. Okay, are there any more people from this section who have a robot to show?
I had a quick question.
Oh, quick question?
Yeah, for you actually.
Sure.
So when you have, so I'm trying to do the tabletop this year. When it finds the block, how does it then find a box?
Well, that's part of the reason for actually 3 levels of IR. One bottom looking down, these 2 in the middle here, shorter range, and basically angling a little down, a little in. And these 2 look way above your object that can see the box. So you need to striate
box is higher than
3.
the block.
Yeah.
I gotcha.
And if there's any other ideas, then I'm open, because that's the.
Yeah.
If you see the goal first, you're dead, because it's going to go find the goal. So, so you make the first 2 nearsighted.
Yeah.
Oh, that's cool, man.
Okay. So, I heard your name, but I don't remember it.
I'm Chuck.
You're Chuck, okay.
Osmond and I are going to go up together.
Okay, okay. Oh, we got a couple of announcers.
So I think the balancer started off with 6 entries, ended up with 4 competitors, and Osmond and I were 2 that were left. We got beat out by an Indonesian team by a couple tenths of a second.
He had a good robot.
We've been, a lot of you have seen Molly before. The latest thing,
Small kids are welcome to come up front. It's perfectly okay.
the latest thing I was working on was the speed to get her to go faster.
Can she balance on the table?
She
extra
can,
credit.
but I want to show you the speed first because she's fast.
Speed on the table.
Fast on the table.
That'll be bad.
And you're welcome to actually come in front of the people sitting down. They won't care.
So, and the thing that got the speed was I had to put a back EMF feedback in to, as the thing got faster, more and more of the energy went into just spinning the motor. So I had to actually change the gain the faster it went. That was the key to getting her to go faster. So I have to show something new
Well, yeah.
when I come, and that's
Yeah.
the new thing.
Yeah, that's it. That's an important insight.
I didn't bring the controller with mine. That was my main downfall at Robo Games. Was I just was running. No, I didn't. I was running. My robot has a Panda board on it. And I was running an access point and just using Wi-Fi to get to the Panda board, using the keypad on my laptop, and it just wasn't good enough. So somebody suggested to use like a PlayStation 3 controller. So that's going to be the next thing I try. So all it does right now is just stand there.
Long term, I want all these things running ROS. So
They will.
I'm sure Melanie agrees with me.
So.
Always.
Always. Okay.
Where'd you find the wheels? The
You're
wheels.
talking to me?
Yeah.
I think these are Traxxas
Okay.
RC car wheels.
Okay. And you know, it's Charles, right?
Chuck.
Chuck. And here's our Bainbot wheels,
Right.
which lots of us use.
But not recommended for a balancer. You want softer wheels like that.
Okay. The green wheels are softer, but I still think those are better.
Yeah.
Okay. Yeah, it wasn't that long ago when we had only one balancer show up. Okay, and, you know, so it's really wonderful to see more and more balancers show up. And one of these days, Nathan, you should bring your balancer back if you ever decide to get a little time to sort of power it up. Okay. Any more? I saw some more hands for robots over here. Oh, Boris, come on. Do you need any setup, Boris?
No.
No, no
I'm
setup.
not really going to show anything.
Okay.
I'm just going to say.
Okay.
Okay, so last meeting I made the Nito Robotics Nito to be controlled with a joystick using a ROS node that I wrote with a little bit of help. So then I did some SLAM mapping, and that was kind of boring. So I thought what to do with the robot. So I realized how many sensors the robot has. It has an accelerometer, LDS, a couple of IR sensors on the bottom, and a wall sensor. That is a lot of sensors. And I had this brilliant idea to turn it into a table bot. Well, with a lot of help from Tully Foot, I wrote ROS topics for the IR sensors on the bottom, so it doesn't fall off the edge. And now I'll only need to write a program, so it just loops around and does the first stage of the tabletop challenge.
Very good.
And you got your help at the SIG, right?
Yeah.
Yeah. Yeah.
Special interest group meets 1 week before the real meeting.
Yeah. And the other thing his robot will do that none of ours could, he will be able to vacuum the table.
Actually, we did have a floor cleaning robot do the tabletop challenge.
Oh, really? Okay. I think it's kind of cool that somebody can say that slam is boring. That's success. It really is. Okay, who's next? Are we out of show and tell? One more.
So this is Dagny. This was my entry in Robo Magellan this year. And
Can people in back hear him?
this is Dagny. This was my entry in Robo Magellan this year. I did about 4th place, I think. And yeah, doing outdoor navigation with a laser and running ROS.
Did you touch bonus cones?
So I got a bonus cone. I never got the
You got
final
a bonus
cone.
cone 2 and almost bonus cone 3, and I think you ended up 14 feet from the goal, right?
Yeah.
It
4 paces.
taller wheels, and you'd be there. The grass
Yeah.
is too thick.
The
They
biggest
didn't go to
problem was
grass
that
this year.
the lawn needed a bit of mowing.
Put a lawnmower.
Lawnmower attachment on it.
Actually, you can't modify the environment. You can't upset the environment. It's one of the rules.
Just give them the day before.
The autonomous lawnmower contest is this summer.
It's not happy that there are no cones in here, so.
Orange shirt. We wear the orange shirts.
Where'd I go?
So, you have to tell us what laser you're using.
So I'm using a Hokoyu
Okoye.
laser. It's kind of on the expensive side, but very, very worth it. And the white disc on here is the sunshade. That means that it actually functions outdoors.
It did.
So the trick with these lasers, most of the time, like they get washed out by sunlight. If you put a big sunshade on them and keep the sunlight out of the detector, they work outdoors.
Useful information. Very good. Okay, are there any more robots? Alan.
Gopher.
Okay.
Gopher's been growing.
Yeah, well, Gopher originally started out as a club presentation. He was shorter. And Gopher is a prototyping platform, and it stands for General Purpose Household Robot. So just like the club has tabletop challenge, I have household challenge. So the first was to have a telerobotic platform that had semi-autonomy. So it has bump sensors and a distance sensor. So while I'm running it telerobotically, it will refuse to slam into the wall or turn away. So what my next project is, and I'm starting to prototype that out, is a door opener. So I'm starting to do that, and it may actually work. Let's see. So the idea is that's the deploy, forward deploy, and I'm going to make a design similar to Aaron Rapaki, who's here, has a one single motor door opener. So the idea behind the door opener.
I'll just fold it up here, okay? Think fast, I'm not that strong.
That's getting some symbol. Okay. The idea is there's a single motor over here that turns, and it's on a threaded shaft. So as the shaft closes up, fingers cinch, and when it locks in, it can no longer cinch, but then the whole thing turns. So the thing will be a single motor that does that, and twists the doorknob. So one of the problems with arms especially is motor count. Every time you add a degree of freedom,
you add a motor, and eventually, even the PR2 arm can only lift 8 pounds, and it weighs what, around 80 pounds? So eventually, the idea is to have simple mechanisms that do more than one thing. So,
Very good.
yeah, thank you.
Any more show and tell robots? Is it Carter or Carson?
Carter.
Carter, come on up.
My robot.
Cool.
Are you ready?
Give him the microphone.
Yeah, talk into the mic, please.
Yeah,
All right.
Trust the table.
How does it work? How do we turn it on?
Yeah, let me take the mic.
Oh, yeah. All right, I'll hold it to his face. All right, what did you just turn on?
I just turned on the, this radio thing.
Mm-hmm.
Yep.
All right. So show us what it does, and then so you can tell everybody how it works. All right. It has a light and a beeper. Does it move? Can you make it move? All right. Now, how does the remote control drive it?
Well,
Where do the signals go? Can you describe what you're touching? What is this?
it's an antenna.
Okay, and then what is this part?
It's
Starts with an R. The radio, yeah. And then where do the messages go?
they go, messages go in here, out here, and then in here.
And what is this?
This is the radio,
M. Motor.
controller.
Mm-hmm. Great. So Carter did assemble this. It came with some instructions. He actually has 3 kits. This one is the most kit-like of them. It's called Snaptricity, and they have these snap circuits. And you actually assemble the circuit on this plastic board, and you use some flexible wires and you use some hard wires. So you actually get to see how resistors work and capacitors and lights, and so you can rewire this where the different buttons would do different things. And then we have accessories that we didn't bring that have fans, and there's an electromagnet, and he rewires it to his liking, and then I give him tasks. I'll put down, so if you have young kids, I'll put down about half of the equipment, and I'll say, finish it. Can you finish the circuit? And then I'll say, how do you get power to here? And he'll make it happen. Anything else to say about it?
How much does that rover cost?
One call to Grandpa.
What do you want, Grandpa?
I don't know.
Well, I don't know if you could do it.
I actually got one lying in my closet, so I can bring it here and just give it away.
Yeah,
Well,
it's a great kit.
What color is it?
Yeah, I'll throw in another vote of support too.
Rather red?
We've got one someplace at Shiloh.
Rather red?
Cool.
Ours is weaponized, but we'll shoot.
All right. Well, thank you, Carter.
thank you very much. Okay. Any more robots for show and tell? Okay.